All right. Thank you so much for coming out on this warm September, almost October evening. I'm waiting for the cool weather. This is the Kubernetes New York City meetup. Please use the hashtag NYCK8 or DO meetup to share what's happening. We'd like to thank the sponsors, DigitalOcean, for hosting us. I'm one of the founders of a company called Stackpoint Cloud. We make it really easy for you to deploy and manage Kubernetes clusters at the cloud provider of your choice, so AWS, Google Cloud Platforms, GKE, and Azure, and DigitalOcean. So if you need things like Sysdig or Istio in the cloud, you want to get it up in about 10 minutes. I hope you'll try us. Here's a code, DOK815. That will give you a $15 credit. If you go there, you'll get it all set up on DO, again, in about 10 minutes. So, announcements coming up. Hacktoberfest 2017. Anybody familiar with Hacktoberfest? Yes, I see some arms. It was actually started by the fine folks here at DO in partnership with GitHub, and it's a month-long celebration of open source software. And the website is now live, so if you go to do.co/Hacktoberfest, you can sign up to participate. There's a kickoff event happening here on October 3rd, so we welcome you to come back then. Next month, Graph Connect. Anybody familiar? Graph Connect. Any hands? 1, 2, yes. Neo4j. So actually, if you hack around with Kubernetes and Neo4j, please come talk to me. We're going to have an event that coincides with the conference. And I have some goodies for you if you do hack around with Neo4j on Kubernetes. And so on October 25th, we'll have an event, the next New York Kubernetes meetup. We're going to be at Squarespace. Beautiful offices. If you haven't been there, I invite you to go ahead and come to the New York Kubernetes meetup page and sign up for it. All right. On to our speakers. So first off, we have Gou from Portworx. That's his Twitter handle. Feel free to share it out with your tweets. He's the co-founder and CTO at Portworx, where, amongst other things, he leads efforts around Kubernetes storage. Previously, he was CTO and executive director of Dell's data protection division. Then after that, we're going to have Akmal. Akmal, are you here? All right. He's GridGain's technology evangelist, and I think he comes to us from London, right? That's right. So his role is to help build the global Apache Ignite community and raise awareness through presentations and technical writing. And so tonight we'll focus on the presentation aspect of that. So with that, anything else from the community? Anybody have any announcements? All right, let's get the show on the road.
Hi, everybody. Thanks for coming out here. This is a good, nice group of people. A lot of people here. Ariel, thanks for having us. My name is Gou Rao. I'm with Portworx. I'm actually here primarily to talk about day 2 operations on running stateful applications with Kubernetes. Before I start, just an obligatory slide here. Please go visit portworx.com/GC. Your chance to win an Amazon gift card for $100. Like I said, what I want to talk about is less about Portworx, but more about running stateful applications in production and running applications in a cloud-native environment. To do that, I'm gonna apologize beforehand. You guys are probably already running Kubernetes, already running stateful applications, but I want to kind of go through some of the basics really quickly and go through some of the lessons that we've learned. What Portworx does is we are a cloud-native storage solution built for applications that are deployed as services in containers by a container orchestrator such as Kubernetes. Almost all of our customers are essentially trying to build a platform or an infrastructure as a service, leveraging modern DevOps tools like Kubernetes, like Docker, containers, monitoring tools like Prometheus, Sysdig, and so on. Essentially, what they want to provide to their end users is a cloud-native experience where people are not dealing with a ticket-based system and dealing with infrastructure provisioning out of band. Now, in this transition that's happening, this transition is sort of in its early stages, right? I mean, if you go back to the early 2000s when people were deploying applications in VMware, things were not smooth. There are reasons that there are VM-centric or OpenStack-centric storage solutions or compute solutions because it's a new paradigm for how you manage your IT infrastructure. And the same thing is happening with the CNCF, Cloud Native Compute Foundation way of deploying applications. And with it comes some problems. What I really want to focus on is not exhaustively all of the problems that we've run into getting our own customers into production, but sort of put them into different buckets. And if I've done my job today correctly, all I want to do is impart some knowledge on the gotchas, the things that you need to watch out for, the type of problems that people can run into, and whoever your storage provider is, what you need to look into from building that overall solution landscape. As an ecosystem, what we're building is cloud. In order to define what cloud-native storage is, I kind of need to set the backdrop what our parsing of cloud-native infrastructure means or cloud-native applications means. As a software industry, we've evolved in how we're building software. It's not monolithic. It's not like software that could be packaged in a VM. I'm a developer. I work with DevOps. I hate tools like Chef and Puppet and that monolithic way of deploying applications. Packaging a service-oriented architecture in terms of containers and deploying them in an inherently distributed system by a container orchestrator like Kubernetes, that makes a tremendous amount of sense for me. So where we're going with from a compute or a user experience perspective is moving to an environment where you or your end users that are building software that are going to run on your PaaS systems they're already being packaged as containers and they want a cloud neutral experience in how they develop and deploy that that CI/CD cycle. They don't want to know about where you're running your infrastructure. They don't want to know that it's on a certain cloud provider, let alone that it's on-prem, and they don't want to deal with IT to get the infrastructure resources provided to them. And this is where Kubernetes does a great job, right? We just go in, we write a deployment script, apply it, it runs, machines fail. As a developer or a DevOps admin, I don't care. Somebody goes in and services the machines when they come up alive. Along the same veins, what we mean by cloud-native storage infrastructure is when I deploy stateful applications, I want that same experience. And my point here is that Kubernetes is awesome as long as you're dealing with ephemeral applications, right? Machines go down, your pod comes up somewhere else, you largely don't care. But when you're dealing with state, there's gravity, and you have to worry about how this is preserved. What is the life cycle beyond the life cycle of my pod? Because those two things are not in sync. What happens if I want to do things like blue-green deployments? What happens if I want to do upgrades? So there's a lot of other aspects to deploying applications, especially stateful applications in a cloud-native environment. I really don't want to talk too much about Portworx here, but I just want to set some context as to why we have some lessons that we've learned. What Portworx is, we are ultimately a software-defined storage solution, but we're built for cloud-native applications that are deployed as containers by an orchestrator like Kubernetes or DCOS. Essentially, what we do is we say, these are fixed resources. On your right-hand side, the storage resources are fixed resources, and an application doesn't actually want to talk to a LUN. Which developer has ever written an application thinking about what will my storage look like? You actually think of storage or state as an external or a serviceable resource. Conceptually, that's what Portworx provides. Our goal is to allow you to build a platform or an infrastructure as a service on any cloud such that your end users can consume storage resources on demand directly via Kubernetes. Their user experience should start and stop with Kubernetes. In an ideal world, they shouldn't know where an application is running or where storage is coming from. And I'll show you a demo of how Portworx works with Kubernetes, but before I get to my Day 2 operations concept, what I want to talk about is it's very easy for people when they're deploying applications with this new way of orchestrating your environment, which is not OpenStack or not VMware, to say, hey, here's my pod. You want me to run MySQL? No problem. I ran MySQL. And that's what I kind of call day one operations. And day one operations are easy. It's a proof of concept. You've just said, I can get an application up and running. And that's almost never the case as to what happens in production. And the main thing that I'm trying to point out over here is there's a lot of lessons that the traditional IT industry has learned that the new DevOps teams should not completely ignore. We have to kind of pay respect to what they've learned in an operational sense. That things, when it comes to storage, there's age associated with it. There's cycles that happen with respect to things like garbage collection, or data gets corrupted, or you lose disks. People need to encrypt their storage. Maybe they're going to migrate from provider A to provider B. All of these are day two operations that are, I think, sort of new to a new generation of people that are starting to manage applications that have state behind it. That's really what I want to focus on. And in order to do that, I'm just going to highlight one thing over here, especially because this ecosystem here is really about Kubernetes. And the main thing that I want to show here is it's important to start understanding right from the beginning where the problems could start. So we all know Docker. And we all know Kubernetes is an orchestrator around Docker. Actually, Kubernetes is an orchestrator around any kind of Linux-based container solution. But specifically with the current releases, it is heavily reliant on Docker. Why I say that is the lifecycle management of how storage gets attached to a container is not really done via Docker. It's done by Kubernetes. It's out of bed. So from here, you start seeing some problems, which is what happens when a container or Docker restarts a container. Who's managing the life cycle of that volume? Is it Kubernetes or is it Docker? And I want to highlight the difference between day one and day two. If you had to go to your boss and say, hey, go deploy MySQL in Kubernetes, it's really easy to get that up and running. But then if I do a Docker restart, who manages the lifecycle of that volume? Was it Kubernetes or was it Docker? Right from there, your day two operations, I don't want to make it sound very scary. It's not. These things are being addressed in the CNCF community, but I'm trying to say that it's a new way of dealing with what can happen to your state. It's not just Portworx that's working on this. So we're working very closely with the CSI community, and ultimately the stack we want as a community to look like is this. There's Rexray from EMC. There's other storage providers. Ultimately, the stack needs to be that you have a cloud-native scheduler such that your end users can run on any infrastructure. That's really the goal, right? Because no developer wants to be bound. You want to create an environment where your developers are really servicing their end users, where they can do whatever they want on and while you're changing the wheels while the car is moving. So you want to provide that kind of experience. And this stack is really meant to do that. Portworx is part of the CSI, container storage interfaces. Just like you have under container network interfaces, you can switch out your networking provider. The things are supposed to be switchable, pluggable, and that's the kind of stack that we're building. You can go check out some of our other open source projects today. I'm going to talk a lot about the day two test tools. That's what this topic is about, how to get applications in production. We have a project called Torpedo, which I'll be talking about and doing a demo around. In order to show you how Portworx works, and I hope my network is going to work over here. Actually, I'm going to switch to. Just want to show you some of the benefits that you get with a cloud-native storage experience. This, again, almost any storage provider you would choose with Kubernetes will pretty much give you this kind of experience. Set this premise up over here. This is my Kubernetes master. Here, I'm monitoring my pods, and over here, I'm monitoring the Portworx volumes. This goes through really quick. When you create a storage class, you can just go in and say, this is all the benefits of Kubernetes. Say, I want a volume, and I want snapshots at every 70 seconds. The point that I'm trying to make here is when you transfer controls from a traditional storage admin to DevOps, their user experience requirements are different. And so when they say, I want snapshots at every 70 seconds, they don't know where the snapshots are going. They don't know how it's protected, and nor should they. They just know that their data is somehow protected. It's like when I use Gmail, I don't know where my servers are, where my email is, but it just always works, right? So it's that experience that this guy is going for. And in that frame of mind, he's going to deploy an application like Postgres and say, go ahead, run Postgres, and gives that to Kubernetes. And behind the scenes, Kubernetes will go ahead and create a Portworx pod, and a Portworx volume gets created, a Postgres pod, and a Portworx volume gets created with it. This is a cloud-native way of provisioning applications. Now, all of this looks cool, and this is all still a day one demo. Things can go horribly wrong, right? After you start running these applications over a period of time, because you have 10 developers that now start Postgres. 5 of them forgot that they're running it. And you have storage being consumed, or maybe there's bit rot, and who's going to go in and take care of these day 2 things? In any event, over here, what I do is I go ahead and kill one of the servers, because 10 developers are running Postgres, one of the machine dies. You're running in cloud, EC2 instances go down, on-prem, servers die. Here, luckily, we have Kubernetes. Kubernetes will go ahead and detect that the node is down. You don't even have to drain the pod. You can just see here, Postgres gets terminated. Over there, you'll see the Portworx volume gets detached, because at this point, Kubernetes is moving the Postgres pod from one node to another node. And when it moves, you'll see the Portworx volume gets spun up somewhere else. All of its data is intact. And this is the sort of cloud native experience that on day 2, you start trying to achieve. But even that is not that easy, because there are other things that can go wrong. And that's kind of really what I want to get to. So switching back to this, what are some examples of failure modes? So now from here, the rest on is really not about Portworx. It's about some of the things that you need to keep thinking about, right? There are various things that can go wrong in this new stack. Why can it go wrong? The reason it can go wrong is because things are getting decoupled. Why are we decoupling things? Because if we're going to live in a monolithic environment, I can guarantee an outcome. But if you want to make a change, I can guarantee the outcome a lot later. But in a decoupled environment, I'll let you make changes on the fly. But with that, I need to add some level of resiliency. Some examples of problems you run into: Kubernetes depends on Docker. What happens if Docker restarts? All your kubelets go down. I was running an application there. What happened to my Postgres application? Did it lose its data? Especially important if your storage provider is deployed as a container, which you would do. Why would you not? You've deployed everything else as a container. Why would you go in and manually install any other piece of software some other way? And the goal here is that we want to move toward a completely decoupled, decentralized model. What happens if I lose my network connection? Here's an example. If I lost my network connection in an ephemeral world, it's not a problem. Kubernetes says, I can't talk to that minion. I'll move this instance from node A to node B. Hold on a second. This is not Nginx requires state. This is not some completely ephemeral application. It was using a volume that was attached on node A. You can't just move that application around, right? So you start running into these problems. So let's look at each one. And this is not an exhaustive list. I'm just trying to go through some examples. And again, this is not meant to be, make it sound like it's insurmountable. It's just categories of things that have always existed, by the way. Network partitions are nothing new. They've always existed. Disk failures are nothing new. They've always existed. But the way in which you deal with them are different over here. And it's not drastically different. It's slightly different, but different enough for you to think about it when you're moving applications into production. So with Docker, actually, I'm sure a lot of you have run into the mount flag slave problem. And I'm going to apologize because I'm under time constraint. These slides are online. There's a lot of good information here, and there's some URLs you should visit. mount flags equals slave, which is just, what is this problem? Well, mostly your storage provider is also running as a container. In order to provide storage services to another container, it needs to be able to share information from its namespace to from within its container to another container. And so you need to enable Docker to be able to do that. Well, Kubernetes, the latest version, still doesn't support Docker, where Docker allows this to happen. So there's some changes you need to make to your operating environment to allow for this to happen. Like I said, Docker in the current version that Kubernetes uses doesn't know that there's a container providing storage to another container. So if I were to shut down Docker and bring it back up, the startup order is non-deterministic. Why is this important? What happens if the MySQL container comes up first, but its storage provider is not up yet? What happens to Kubernetes? There's a lot of, and like I mentioned, the state provisioning for storage in Kubernetes is out of band. So there are issues there as well. Docker itself could have instabilities. Docker could crash. If Docker crashes, what happens to my storage volume, right? Did my storage provider come down? So there are things that we've done with Portworx where we've decided to run Portworx as a container, but outside of Docker. We run it just as an OCI runc container. These kind of things just make it a little bit easier to get a workaround maybe others. You don't want to build a matrix like this, where the dependency matrix is so complex that A depends on B, B depends on C, C maybe depending on A, and it's just, you don't know where to stop, right? So you want to go with a solution where everything is containerized, but independently testable, isolatable, and you can cause some sort of chaos to it that won't perturb the overall system. The second one is, what happens if I have a network failure? And this was the earlier example that I was giving, where Kubernetes can't see a particular minion and it decides to abruptly move the pod over from minion A to minion B, but the volume is still attached on minion A. And these are type of problems that you wouldn't happen in an ephemeral world that you will definitely run into day 2 or day 1.5 when it comes to storage. Somehow with storage, invariably things start going wrong very quick, right? Because your end users are going to push different kinds of load that they didn't push on a stateless system. Storage can cause various types of havocs on a host machine. It's not just memory and compute. They can abuse the page cache. They can push the system into swap. If they push the system into swap, why is this important for me? And I'll give you a real example. If you're dealing with traditional storage today where your application is running in a VM and storage is coming off of a NetApp, does NetApp care if your host machine is running into swap? It's separate, it's external, it's going to continue to run. But here, by definition, you're building a converged environment. So if your application is going to abuse swap, that can impact storage, which can have cyclical effects. So these type of things can cause outages, unavailabilities that you need to keep track of. You can have a disk failure. So Kubernetes knows about a machine not being available, but does it know about a particular disk being bad? And what if it's going to schedule an application on that node where a disk is bad? How do you mitigate around these? Do you cordon off the node? That sounds a little excessive because there's good compute and memory there. Maybe I just don't want to use storage resources. So now you get into a pattern of where you need to think about operators and a framework for being able to add storage intelligence to your scheduler. And so with Portworx, we have built that kind of intelligence into our driver, and we try and mitigate those things. And I don't want to make it sound like this is all a solved problem, not even by us, right? It's a evolving area where we're also learning about use cases, problems that can happen. Kubernetes is still in the 1.x, and it's evolving. I'm going to, in the interest of time, kind of go through this. You can look at this. Upgrades is another important thing. Ephemeral, upgrade, right? You don't care. Just upgrade at will. But with storage, you have to have a sensible upgrade strategy where pods are correctly drained, brought on other nodes, but is there data available over there? So these are just really important things, because even in just upgrades, you're going to have blue-green deployments. You're not just going to willy-nilly just upgrade cluster A to cluster B, especially because without state, rollback is easy. But here, you want to make sure that you run sufficient tests against your MySQL Postgres database and then roll things back. So what we've done is we've built this test tool called Torpedo, which is really what I want to talk about. I think we have some cool stickers there with a pig riding on a torpedo. The goal behind this is to provide a vendor-neutral way of making sure that you, as you deploy your application in production, are day 2 production ready, right? And the motivation behind this was DevOps moves at a different pace than traditional IT for good reasons. But with speed comes, you can make mistakes. And this thing is really to put checks and balances in place to make sure that as you're going to roll this into production, have you thought through all of these things? And it runs through a battery of tests. Think of it like a chaos monkey, where it will go in and do weird things like kill Docker, run things out of memory, reboot a node, kill your storage provider. And it's open source, and it's goal is to qualify any storage provider you would choose. It's not just for Portworx. It could be for Rexray. It could be for any other external storage provider. So I'll just kind of end with a quick demo on how that would work. So just the premise over here is, again, same theme, kind of watching what's happening to the Portworx volumes, looking at the pods. And Torpedo applies as just install it into Kubernetes. It's very Kubernetes specific. It knows about your Kubernetes cluster, is going to SSH to those machines and do destructive things, right? So you don't want to run it on your production cluster, but it will go in and kill pods. It will launch an application, wait for things to start, stop, make sure that the data is intact. So it's an ongoing project. We're trying to get more industry momentum behind this. So you'll see here, as soon as I started it, it went and started a Torpedo container, which is the actual master container, which in turn will spin up different applications like Postgres, Nginx. It tells you the type of tests that it's running. It is abruptly trying to tear down a volume. And as it's tearing it down, if you're monitoring Portworx, you can see how Portworx is coping with this chaotic environment. Obviously, hopefully your production environment isn't this chaotic, but you want to make sure that it's capable of dealing with this kind of chaos. So it goes in, and now at this point, it's going to do a complete node reboot and make sure that storage is capable of dealing with it. And at all points in time, it's testing the application to make sure that the application is available. It can retrieve its data. You can see here that it's rebooting a minion node. And there's a UI associated with it too. Typically what I would recommend is you would run something like this in your pre-production environment, let it run overnight. You'll go to a dashboard. You can see all the tests that ran and potentially things that failed. You can see some failure modes there. You can see if the basic test passed or if a particular test passed. Maybe some tests aren't relevant and you don't care about them. And if you go to a particular test case where you see some warnings, it will tell you where in the pipeline that it passed or failed. So I'll be around. I'm sort of out of time. Questions? Yeah, please.
Hello. Hello. Hello.
Oh, okay. Two mics.
I have a couple of questions for you. When you were implementing snapshots, how are you implementing those? Is that thick or thin?
So snapshots so now this is repeat the question. The question is, when we implement snapshots, how do we do it? This is a Portworx specific question. Your storage provider may do things differently. In Portworx's case, it's thin. And we don't rely on the underlying storage provider snapshots. And the reason for that is, in our case, our goal is to provide a cloud neutral layer for implementing this. Your backend storage provider, whoever it may be, may or may not provide that capability. So we assume in the backend nothing, that as in just basic persistence and failure capable persistence, right? We assume that it's going to fail, and so we add that layer of resiliency on top of that.
Okay, and then the last one. Do you have support for like FC?
Sorry?
Do you have support for like FC, like ISCSI for legacy storage?
Oh, no, that's good. Portworx specifically does not support legacy applications, so we don't support a VM environment. Quite frankly, there are better solutions for that, better products. The question is, do we support like iSCSI VM-based? We don't, and there's a whole different set of requirements around that I think that there's a lot of other better products for that, including just even in the OpenStack environment. Our goal is to provide stateful services, whether it's file, block, or global namespace or object, to applications that are specifically running as containers, want converged storage.
So I have a question about Torpedo. I used to work in a tech company that, as part of their part of a resilience project, they had a weekly or biweekly chaos that they would put onto their production network, and including clusters of systems that were serving production traffic. And eventually they reached a level of maturity where that was non-disruptive. Can you think of any reason why, or are the Torpedo tests themselves, do you think that they would be suitable for companies that are aiming for that kind of high level of maturity?
That's a great question. It is possible. So Torpedo is still early, and so it is possible to have Torpedo Co reside in your production environment where it's inducing a minimal amount of chaos. The reason currently I would hesitate to do that is if you even went to our GitHub, you'd see that this is a fairly early project. So I don't know if it has enough constraints to really guarantee that it won't cause disruption, but that would be the goal, to add some minimal amount of chaos while that's happening. That's a great point.
Do you, on your roadmap, do you have any plans for clustered storage, vaulting, anything with a Gluster file service? Anything to really push to that traditional, tier 1 type of storage configuration?
Yeah, so we are a clustered storage solution today. So we do serve only tier 1 storage, actually. We have, like I was mentioning earlier, we support distributed block, distributed file, and distributed object to tier 1 applications. But the comment around Gluster is, unlike Gluster, we're not really a good solution for, I guess, just a traditional NFS-style application mount use case. A lot of the, again, there's a Portworx-specific value conversation. That the Portworx's differentiation when you're looking at something like Gluster comes into play when you're deploying applications through Kubernetes as containers and want that experience. Our software is designed to cater to the DevOps audience as opposed to an IT audience that wants to deploy some infrastructure and then give some ways that other users can access it. Short answer to that is, I think Gluster, for what it's done, is a much better solution if that's the use case.
Sure. But how about on the vaulting side? Because especially in healthcare and financial services.
On the vaulting?
Vaulting.
Yeah.
Vault, like data vaulting with storage vaulting. You're creating storage persistent volume vaults, right?
Got it. We support encryption. We actually integrate with third-party tools like, I know this isn't your usage of Vault, but like key management software like HashiCorp's Vault, where we can create storage vaults, and the keys are managed externally. And again, those storage volumes can be block, object, or file.
Excuse me? Yeah. Question?
Oh.
Yeah. So when you're mounting, let's say, a Portworx volume inside of a container, how is that exposed to the operating system? Is it a driver? Is it a
Great
service?
question. It's a local block.
Okay.
And it's exposed as just another block device. And it's done through block fuse.
Okay.
And this is one of the, again, I don't really want to plug Portworx here, but one of the challenges that we've found when you're orchestrating external storage devices into containers is there's a layer involved where you're providing iSCSI to the host and somehow doing a mount of that iSCSI volume into the container. And that's where a lot of things start going south. And where in Portworx, there's a container running on every host, and it just exposes a local block device. So if you were to look under /dev, you expect to see SDA, SDB, and so on, right? As containers come and go, you'll see virtual devices like PX1, PX2. And the reason that this is important is because those are really, for the kernel, that's a natural thing to deal with. It's almost as if you moved a container from server A to server B, it's almost as if you took the drive out and plugged it somewhere else in.
Okay, thank you.
Hello? So my question is about Torpedo. How customizable are the things you can do with it? Like, can you say, have a preference towards, launching, essentially, how customizable is the chaos that you can induce with it?
It's somewhat customizable. The definition of customizable is going to be dependent on what you have in mind. Torpedo's open, and honestly, the reason I'm here is to solicit, like, this is the ecosystem, right? This is the ecosystem of users that are going to use it and run applications. And I really don't want to sound like, we have all of the operational experience or anything like that. If you have certain use cases in mind, that's what we're looking for. Like, tell us what you would want to do, or maybe submit a pull request or a change, or submit a issue. I think it's designed to be customizable with all of those things, but are all the hooks in place? I would doubt it.
Hey, so disclaimer first, I've never used Portworx. So my actual question is, why should I use Portworx over something like RexRay?
I think one of the main differences are going to come in from this, where RexRay is a good product. Okay, if I had existing storage already and I didn't have a highly changing environment, I would probably use RexRay because it provides a convenient method for me to connect my application to my existing storage. Where Portworx would be important is if the following things are of interest, right? Completely programmable layer that your end users can do adds, moves, and changes directly. More importantly, where they want to deploy applications that I think that are more cloud native today, like Cassandra, Mongo, which require local storage, which require hyperconvergence of some sort. Finally, the thing is, Portworx is not really we are the entire storage solution, right? So where RexRay is trying to coordinate an external volume, we implement the full stack, and the stack is cloud native. What is an example of that? If I encrypted something, with Portworx, the encryption is just happening even before Portworx sees it, at the kernel, at the block device. So how is that different? If I wanted to move my data from Amazon to Azure, I'm not decrypting or re-encrypting. It's just that it was encrypted end-to-end because it was done at a layer above the underlying storage. There are other things that I can go into. Obviously, RexRay is competitive to Portworx in the sense that, but again, it's ease of use. If you have existing EMC storage and you just want to have it connect to your connectors, RexRay is a fairly easy, off-the-shelf thing to start with.
Cool. Any more questions? Time for one more? All right. Gou, thank you so much for that. Akmal from GridGain talking Ignite.
Okay. Can you hear me? If you can't hear me, raise your hands. Cool. Okay, guys, so I know it's late, and you're probably dying to go home. Those of you who've got homes to go to. Right? If you're a developer, maybe you haven't got a home. It's screen, laptop is your home. So I'm going to keep my presentation fairly short, and it's going to be a lot simpler than the last speaker. So he covered some really cool technical stuff. I'll be a little bit less technical, and just give you some kind of insights into something that you might want to think about. Okay, so A couple of slides on me. So apologies, it might look more than I should present, but the thing is, when you get to my age, and you can see, gray hair, white hair, no hair, it's kind of difficult to summarize your entire life just on one slide. So bear with me, all right? It's could be useful. Could be useful for you guys. Okay, so basically all this says is that I've done a lot of stuff, right? So I've worked for a variety of companies. Real-time systems, relational databases, that's how I started my IT career in London, working for Reuters. Fabulous company. It's like working with 21st century technology with 18th century culture. And it's enormous fun. I work with some of the brightest and smartest people I've ever met in my life. They taught me a lot. I pestered them, and I cajoled them, and they were really, really helpful. So that's how I began my career. I became an academic, so I got into the database performance benchmarking space. And in those days, in kind of 1990s, it was object-oriented databases. That was the big thing, okay? It's going to take over the world. Relational was dead. 10 years later, XML came along. That was going to take over the world. Relational is dead. Today, what is it? NoSQL? Never going to happen. Trust me. These guys are just full of hot air. It's look at the Mongo S1. They're making $100 million, 90 million loss. Where is the money? Open source has its benefits, and trust me, I speak with someone who's worked in the open source space. So I work for Hortonworks. I work for DataStax, so I know how it works. So the kind of general model that we tend to use, give your software away for free, and then essentially you offer enterprise kind of features, training, support, bug fixes, and this is the kind of thing that, for commercial deployments, people tend to look for. It's very, very risky just focusing on the open source. Having said that, I think it's a cool way to go, and what I've observed over the past 15, 20 years, as the open source movement has really grown, that there is far more confidence today. A lot of the financial institutions years ago, for example, they were very, very nervous, What's the licensing, Who does the bug fixes? Can we look at the code, Can we modify it? All of these kind of issues are important. Today, if you look at the financial world, and especially because, they tend to have deep pockets, so those guys can afford it. They can buy the best talent, they can buy the best technology, but even they are using open source today as a way to cut costs, as a way to get quality. So Ignite, Apache Ignite is what I'll focus on today. So again, just some cool stuff, and again, all that says again is I worked on lots of stuff over the years, lots of technologies, client-facing roles, 10 books, and these make wonderful gifts for family, friends, loved ones. If you're looking for a Christmas present, I encourage you to consider these. You'll see how old they are. Look, object-oriented databases, XML databases. All right. There you go. I used to get a royalty check for about $25 every 6 months. Even that doesn't come anymore. Nobody's buying this stuff. So I need the day job. And what it is, okay, so I was an independent consultant, and then GridGain came along, and they kind of interviewed me and said, right, we need someone to help us build the community, because we got this cool technology. It's called Apache Ignite, and we want you to help us spread the word, all right? And I thought, fabulous. So someone's paying me money to talk about open source. I'll take it. I'll do the job. And so really, that's my motivation, to help them talk at these kind of meetups, presentations, get people interested, okay? So there isn't too much technical stuff today, but just to get you something, awareness, maybe get interested in this stuff and have a look at it. It's pretty cool technology. So let me just show you a couple of things. So let's have a look. These HDMI is annoying. Let's see if there's anything I can do. There we go. There's a little bit better. All right, so ignite.apache.org. Okay, that's the website to go to. You can download the source. You can build it, fairly standard, or you can do the binary distributions. Basically, all you need is Java. That's all. Okay, that's all you need installed on whichever environment you can run it in. This thing will work anywhere, pretty much so. Okay, so it will work in the laptop, virtualization, Docker, Kubernetes, Azure, Google Cloud, wherever you want to. And there's a whole kind of range of mechanisms available that these nodes, as they're sort of fired up, they'll find each other, okay, if you've configured it correctly. Multicast and all sorts of other things, static IPs. Excuse me. So this thing is pretty cool. If you want to just kind of do this, I've got a blog on the GridGain website, but for some reason, someone thought what I'd written was quite useful. I don't know why, but they recommended D-Zone should pick up my blogs. So if you go to D-Zone, do a search on my name, there's stuff coming out. And I think today, sometime, there's going to be an article on how to get Ignite running on Kubernetes on Amazon Web Services. And I pulled my hair out, look, trying to figure out how to do that, right? It was really, really hard. Documentation is awful. Everywhere you go, poor documentation, okay? So this is a kind of a problem for the open source community. I talked to my boss, and he said, it's open source. I said, I know, but why is the documentation so poor? Everywhere I go, I want to find how to do this, how to do that. Someone, things have been deprecated. No one's updated the documentation. I can't figure it out. And now eventually, I managed to sort it out, got it sussed out. It's a fairly long article, but quite a useful one. So there, the pains of, there's my effort. 90% of that is trying to figure out how to get Kubernetes installed on AWS. Okay, 10% is just the Ignite bit. Okay, really, really easy. So I'll show you how to do that. We've got Minikube, and I've got a demo showing how to actually get this running in that environment. All right. So a couple of other things. Feel free to reach out on LinkedIn, okay? So that's actually one of the best pictures of me when I had black hair. It's actually a wedding picture, So when I got married, my wife is Chinese, by the way. So when we got married, she said, we're going to have some wedding pictures taken. I said, great. I brought my suit, white tie, red tie, white shirt. And I thought, we're going to spend an hour at the photographer's. 9 hours later, 6, 7 changes of clothes later, and that was the best picture that they could come up with. So there we go. Feel free to reach out, okay? Just connect with me, and you'll have a great time because we'll exchange some real cool stuff. All right, so back to the main show. All right, so that's enough about me, and let's switch to Keynote. And so, like I said before, this is fairly simple stuff, okay? You guys, you're technical people. You know all about Kubernetes. I don't need to tell you all this stuff. But just to give you a little bit of insights into how to get Ignite working in this environment. So we'll say a little bit more about Ignite and why you should be looking at it, thinking about it. Okay, so in terms of the agenda, cover a little bit in terms of use cases, and then a few slides just to show you how to get this up and running. And as I said, I got a demo with Minikube that shows this working locally. One of the problems I had with Minikube on the Mac especially is that what I didn't realize is that to get these kind of persistent volumes working, you need the X-Hive driver. It doesn't work with VMware Fusion, or at least I couldn't get it working with VMware Fusion. So again, more hair pulled out. It's one of these problems that unless someone tells you this, or you can Google it and find the information, it's really, really hard to find this stuff, especially if you're a newbie. And I'm a newbie, okay? So I'm new to this space. Although I know a lot about Docker, Kubernetes is a kind of a new space for me. Okay, so Ignite. Anyone heard of it, by the way? I forgot to ask. Wow, a few of you. Okay. All right. You guys should get T-shirts. Tom, where are you? T-shirts, please, for these people. Okay. Are they still there? We got still some left. Okay. Fabulous. All right. So in one slide, what is it then? It's an in-memory computing platform, durable, strongly consistent, highly available SQL key-value processing APIs. All right. So originally started life as an in-memory data grid, key-value caching layer. Okay. Designed to address two main problems, performance and scalability, all right? So you know that running things in memory is super fast, okay? You don't want to read stuff off disk. Historically, if you look at the relational world, for example, those guys, Oracle, IBM, Microsoft, they came from a different age where memory was tight. So you had to go for things like disk-based optimization, and that's what SQL was designed for. Today, of course, memory is cheap. Lots of things you can cache, and conceivably, you can have enough memory, you can cache your entire data set as well. Some risks attached to that, of course. things might go down, your cluster might die, all your data is lost. So what they added to this was this kind of durability. So this notion of being able to store things on disk, right? And you can do that a couple of ways. There is something that's supported directly through Ignite, its own persistent sort of mechanism, or you can plug into a third party, such as a relational system, HDFS, or even a NoSQL database, okay? So it's entirely possible to do that. And again, the motivation is no rip and replace. It's complementary, okay? It's not designed particularly to replace anything, but to help you achieve better performance with what you already have. You can use some of its additional capabilities if you want, okay? So it consists of a series of components. So there's a data grid, key value store. There is a compute grid, okay? And the way it works is very similar to kind of MapReduce. It's called fork join. You may have come across it. There is streaming. So if you're working with technology like Spark Streaming or Flink, for example, or Kafka or something like that, there are adapters, okay? Allow you to stream data in. Ignite can act as a sink. Okay, once it's in there, you can define a window, for example. You might want to keep the last 10 events or the last 5 minutes worth of data. You do some processing on that. Okay, so there's a machine learning grid. You can apply some machine learning techniques, or you can query it with SQL if you want. That's entirely possible. And then, again, you throw that data away, and then you wait for the next window or opportunity. High availability, okay? So the fact that we're using a cluster computing, means that it gives us lots of capacity, lots of redundancy, the ability to spread that load, have a primary copy somewhere, have backup copies elsewhere, and that gives us the high availability that we need. Recently, they've added SQL support. So okay, SQL 99, it's fully compliant. So if you're working with things like MySQL, Postgres, other technologies of similar ilk, it will work just fine with those. Key value, okay? So maybe you've worked with products like Redis, for example, which is also a key value store, and again, has some kind of caching technologies. But this is similar in some respects, but broader as well, in the sense that it's much larger platform. And the value, of course, can be anything, okay? It's not just simple types, but complex types as well, and as complex as you want. So yesterday, for example, Tom and I were presenting a session on the use of Ignite, for example, for financial applications. So things like financial trades. How do you store these kind of things, and financial instruments. These things can get very, very complex. And variety of processing APIs. Okay, so natively Java, obviously, because technology is built on Java. .NET support, C++ support. These are the three kind of strong ones, if you like, in the sense that if you've got teams within your organization who are working on one of these programming languages, that data can be shared across the other two as well. There is a binary format that's used, okay, natively by Ignite that allows you to share these objects that you're storing within the cache and be able to work with them directly. So other language support is available as well. So there's ODBC, JDBC as well, in order to give you access from some other environments as well. So fairly comprehensive, okay? But this is a kind of a nice high-level summary of really what it is. There are, of course, competitor products out there. You may well be using some of them. Hazelcast comes to mind. Oracle Coherence, maybe. These are possibilities. And then again, there is some overlap with some other products and technologies on the market too. Things like Redis, for example. That's a great key value store as well. And it does some other cool stuff too. OK, so 50,000-foot view. Essentially, this is the core of the technology. Okay, memory-centric storage. But that memory-centric storage doesn't mean it's just caching it. It's just in memory. We have the ability to do native persistence, okay? So it adds some capabilities to be able to write stuff out. That gives us the durability. Very, very important. And again, this idea of no rip and replace, okay? So if you're working with some existing relational system, HDFS or NoSQL product, you can use that as well, all right? You don't have to throw that away. There's no need to do that. On top of that, then there's a whole range of these different components that come with this. And again, in my blog series, it's on dzone and on GridGain. You can have a read of this. So my boss got me to write an article on each of these things over a period of time, over the last couple of months. So one reason they hired me is I knew nothing about their product. Great position to be in, okay? I come with no baggage, I have to learn as well. So as I learned stuff, I wrote about it, and hopefully it's useful to other people as well. So SQL, key value transactions, compute grids, services, streaming, machine learning, there's a whole range of these other things as well. And the machine learning is pretty cool as well. So at the moment it's in beta, supports matrix algebra, but there's other cool stuff coming along as well as things are developed. And then on top of that, of course, the variety of applications that you can apply it for. So on Monday, for example, Tom and I were at an IoT meetup in New York. We were talking about how this could be used, this type of environment could be used for IoT applications, wearables, meters, these streams of data coming in from sensors and other devices. And you can use the various adapters that the technology comes with, Spark streaming, Flink, whatever, and again, be able to stream that data into Ignite, do some processing, enrich it, and then be able to take some further action on that to get some business insights into this. And earlier today, I did a webinar covering the machine learning, for example, and looking at some of the applications of that, of which I picked the pharmaceutical industry as an example. Okay, so in terms of looking at this kind of another way, so we've got server nodes and we have client nodes, okay? And then all of those things that we covered in the previous slide in terms of the kind of things that we want to do. One or two things, again, worth noting here, ACID transactions, okay? So what Ignite has become is a distributed relation, well, it's an SQL database, okay? Fully ACID compliant, atomicity, consistency, isolation, durability, and in many industries, financial being one of them, this ACID compliance is quite important. You have to move from a known state to another known state. Things either get done together or they don't get done at all, right? So this eventual consistency thing, which many of the NoSQL products use, not really used here. But having said that, transactions can be both pessimistic, okay, we take out locks, or could be optimistic. Optimistic could be very useful in some environments. Here I'm thinking of CAD/CAM, for example, where typically a designer or someone sitting at their workstation, you check out a part of the design onto your local machine, you work on it for a period of time, and you check that back in to the central repository, and there's unlikely to be conflicts with other changes that have been made by other members of the team, because you are just responsible for that part of the design. So that overcomes some of the overhead in terms of locking and other issues, but then there's a risk that some updates and changes don't really get applied. Okay, and then just to give you some examples of this kind of applications and industries, you can see some well-known names there. And again, if you have a look on the Apache website, there are documented case studies showing some of these, the different industries, the different verticals, and the types of applications that people are actually using Ignite for. Okay, so I told my colleague Tom that, with this Kubernetes stuff, I could actually show everything about Ignite on one slide. So you can see I had to pan things out a bit, in order to make it worthwhile. So, but the thing is that let's go through the steps, all right? This is pretty simple stuff. You guys will understand it without any problems, okay? So the main thing here is that in a cloud environment, typically, and this is taken directly from the article that I wrote on how to deploy it on Amazon Web Services, it's fairly straightforward, okay? So it's just created some nodes there, pods. And then here, what we've got is just having a look at that in a little bit more detail. So this is on, as you can see, it's a little bit constrained. T2 micro, not very useful, but I wanted to save money. I mean, don't want this Amazon to get too much of my money. These things, you forget they're running, you get charged on your credit card. This happened to me last year. I forgot some stuff was running. Amazon billed me, and I was horrified because it's my fault. Can't blame them. But again, just as a way to test and see things are working okay, that wasn't bad. All right. By default, of course, when you do this, when you set it up, okay, you have something that's actually larger. And as you know, you guys will know that when you're creating these containers, that you have the option to specify at creation time what it is that you want to use. And I chose T2 micro. So not very useful, but it proves a point. In terms of the dashboard then, so that's fairly standard. No worries there. You should be able to that should be quite familiar to you. However, something that may not be familiar to you. So if we're running Ignite within this containerized, orchestrated environment, these nodes, Ignite nodes, need to be able to find each other, And therefore, we've got a little bit of work to do. So we have created a special service, right? So this service, so when an Ignite node joins, it knows where to go to be able to find all the other nodes. Otherwise, these guys will fire up. They can't see anything. They don't know where anything else is, all right? So again, I'll show you an example in just a moment. But there's multiple ways we could do this, okay? So multicast, static, cloud, Kubernetes, all right? So this is a fairly important step, okay? The rest of it is fairly basic, but again, my boss told me that you who are pros and know this stuff like the back of your hand, you'll understand why we need to do this, okay? It should be fairly obvious. Okay, so the lookup service then, it maintains a list of Ignite IPs, okay? So the Kubernetes IP finder communicates to the service, and we get a couple of things, okay? So new Ignite pods obtain the list of the existing addresses, okay? So they know what else is out there already. And then pod joins the cluster via one of the addresses, okay? So it's able to take an address, and then this way it's able to find the other machines and be able to join the cluster. And that's, I think, pretty important. So once the servers Ignite nodes have found each other, I mean, it'll come up. We'll see that in just a moment in terms of the demo. So here's the YAML file that we need on the left-hand side in terms of getting this Ignite service up and running. All right? Very straightforward, extremely simple. And here's the command that we use to run to be able to register that. And again, we can check the status of that using the dashboard. A bit more required here in terms of deployment. Okay, so that's hard to read. Don't worry about that. Okay, so all of the code, I'll be happy to provide that to you if you're interested. And it's actually as part of the article that I've written. But there's a fair amount that's going on there. So we have a config URI that points to something. In this case, it happens to be on GitHub that it needs to pick up some information. But this is the actual deployment YAML that we need. And then the next step, once it's up and running, we can just drill into looking at one of these pods, have a look at the log file, check to see if it's working OK. And I'll try and zoom in if I can and see if we can show you anything there. But here you can see, for example, this is the very same T2 micro example that I was using. So you can see that it's servers equals 2 right on the bottom line there. So these nodes have been able to find each other, and that's good. Okay, it shows a healthy state, and everything is working okay. Okay, and it's very, very easy to scale the cluster as well. Don't try this on T2 micro. It messes things up badly. Your machine hangs, and it complains. Basically, not enough resources. Okay. You've got to try this with something a little bit bigger. So if you want to scale from 2 to 5, I mean, you can do that straight away. Again, just passing this command to Kubernetes, and then, again, same deployment file, but here we're saying replicas equals 5. Okay, so elastically being able to scale, and then you can do this down in the other direction as well. If you find that you don't need so many, but you want to get this down to 2, for example. Okay, so let me show you. Okay, so that's pretty much it. I told you it was really simple. Okay, there's not really much to it. A couple of things that you need to do in order to get this thing working. All right, and I'll blow this up in just a moment. Okay, bear with me. Being slightly handicapped, okay, I'm going to cheat because I'm terrible at writing and terrible at typing. So if we just blow up this and have a look here. All right, so this is what I've got here, Minikube using Xhive. All right. And let's just try and get that a little bit centered here and so on. As I said before, I was pulling my hair out because with persistent volumes, it doesn't work unless you use this on a Mac. Okay, I don't know about Linux or Windows. Unfortunately, as you know, it's kind of tough to run a virtual machine inside a virtual machine. You can't do it, all right? The things, it needs to pick up stuff from the BIOS, and then the virtual machine doesn't have that capability. So the only solution to be able to test the various drivers, especially if you want to use Minikube, is basically you need a physical Windows machine or you need a physical Linux machine to be able to do this. And of course, on Linux, as you know, you can use things like KVM. On Windows, there are other things as well. By default, it will look for, what is it? It's VirtualBox, isn't it, from Oracle? I think that's the default that it searches for if you don't specify this. But the Xhive driver, once you've got it installed, so there we go. So Minikube is up and running. Cluster is configured, all right? So let's do this. Let's use that YAML file that I mentioned, the really simple one, okay, to create that service. Okay, that's very simple. Oh, it doesn't exist. Let me have a look. I know why. It's because I'm in the wrong folder. There we are. That should be okay now. Yeah, there we go. So the service is created now, okay? And we'll look at that in just a moment. Okay, so sorry, I'm a bit slow. It's, there we go. Okay, so if you can see, there the service is created, okay? So it's port 9042, TCP, age 21 seconds. Okay, almost done. All right, so that's ready. Now what we need to do is to do a bit of work in terms of getting some volumes, persistent volumes, and we'll do that first of all. So, okay, so that's done. Ignite volume, and don't worry, we'll take a look at this from using the dashboard, so it'll be quite nice to see that directly. Okay, that's the next step. All right, so we've claimed the Ignite volume, and then now let's do a deployment. Okay, so Ignite cluster created, all right? I think it takes a few moments just before we get anything reasonable back from this. I mean, it's a simple environment, but I think Minikube is quite useful just for a little bit of testing. So as you can see here, it's taking a little bit of time, okay? So not quite ready yet, okay? So as part of the YAML files, we specified we want 2, all right? And there we've got 2, which are kind of in the process of being created. These containers are underway. Let's have a look again, see if we can get anything. Okay, it's still taking a few minutes. In the meantime, I suppose we can shrink this back down again, and we can have a look at the dashboard, see if we can fire that up, and then be able to have a look at all right, so that tells us a little bit. All right, so we can see that there's some progress. We've got our pods. Still waiting in terms of container creation. And if we have a look at the services just down below, we should be able to see that there we have the Ignite service running correctly. And we've got our persistent volume claim and everything else there. That looks good. Let's just try and refresh this, see if looks like it's still trying to still taking time. Apologies, I mean, it's a minute. We're impatient. We want instant gratification, you know. What we tend to do is years ago, and I'm not quite that old, that we used to have punch cards, okay? That's before my time, but remember in those days people had to write their COBOL programs and they had to be very careful. You spend a day doing all these punch cards. If there's a mistake, you will lose a whole day's worth of effort, all right? Today, of course, we can just type things and off we go. And of course, we've all got one of these. And, you know, Try and sit on the train next time you're traveling and look around you to see what people are doing. They're like this, you know. Nobody talks to each other, you know. So anyway, let's have a look. See what's going on. There we go. So everything's up and running now. So we got 2 of these pods running. And I think if we refresh from here as well, what's this? Just deny that. Not cool. OK, there we go. So no restarts, which is, I guess, a good sign. Age 2 minutes. And we've got a couple of those. And again, very, very simple, because we're kind of pressured for time. I think I need to wrap up. So again, in terms of scalability, we can just do that replicas equals 5 command, which would give us 5. On this environment, it's kind of tight. Doesn't work too well. Okay, doesn't scale too well. This machine is a little bit underpowered as well, which is a problem. So my apologies for that. So, OK, so hopefully that's been reasonably useful for you. OK, so at least you've had an introduction to Ignite. You get a little bit of an understanding of what it is, the fact that you can deploy it in this type of environment, which you guys probably use day in, day out. And it's another option, OK? So it's another way to be able to use Ignite in this type of environment, which could be very useful, OK? OK, any questions?
So I'm actually probably more familiar with Ignite than I am with Kubernetes, but the Minikube environment looks very nice for some of the testing that I would want to do, especially for high availability, sort of following what the last presenter was saying, having like a chaos monkey kind of thing, kill random nodes, bring them back up, and let's see what happens. So that's something that testing that I've actually done with Ignite just on random VMs. Would I be able to, just using that Minikube environment, would I be able to basically see the behavior of like timeouts and failed networks basically across the Ignite cluster just by taking up or down one of those Ignite instances?
It should work as standard. Okay, so the gentleman was really asking, you know, is the Minikube environment good enough to do some reasonable level of testing? And I think yes and no. I think it's great for individual laptop type deployment, just to fire things up, just to test them a little bit.
Right.
But really for enterprise level and the kind of things that the last speaker was talking about in terms of Chaos Monkey and all those kind of things, you want to run on production systems, no way.
Well,
simply.
No, I understand. It wouldn't be good for load testing, but
Yes.
let's say I want to do a basic integration test and
Yes,
see if my
yes.
exception handlers are actually going to fire
Yeah.
when I break everything.
Yes. So I think Minikube, I mean, if you look at the versioning, it's 0.2 or something.
Okay.
I don't know.
Okay.
It's still under development. But I found it, and again, I can't set up an AWS cluster here for you very quickly. So just for demo purposes, this is pretty cool. And then I think the kind of scenario that you envisage in terms of doing some basic testing and being able to play around with it, I would guess it should be okay. It should work reasonably
Basically,
well.
just stressing the system, just seeing what exceptions get thrown when you're in the JVM and bad things happen.
Small scale, I think, cluster, that should be okay. I don't think, I mean, again, my machine is a little bit underpowered, but if you've got enough RAM and you can set this up in a way that gives you, it's local, it should work reasonably well. You can create a small size cluster that should give you the opportunity to test it within a controlled environment just to see how the behavior is. That should be quite reasonable. Yeah.
Okay, thank you.
Right.
Questions?
Okay.
No? All right.
Okay.
Oh, over
so
there.
I guess just
Hold on. One more over there.
One question. Yes.
One quick question. So, most of us that I've ever used any of the caching databases, like I've used Kubernetes for a long time.
Yes.
You have a very tiered model, thank you, in how you develop. So it's in some ways kind of replaces the TP monitor in the old days. How do you develop to leverage these features? How do you develop differently? Because you're in some ways you're kind of overlaying caching solutions is what you're doing today.
Yes.
And so it doesn't really disrupt the monolith too much, and it just gets more life and higher performance. But with this, you're it's like a rip and replace and caching the monolith at the same time. I mean, how have you seen the patterns or the way this that you can develop? Does that make sense? I mean,
Okay. Yeah, kind of.
blurry,
Okay,
but-
so I think what the gentleman is asking really is that we've got a lot of components, and in addition to the caching capabilities, how easy or difficult then is it to actually build systems using these various options, because it looks quite rich. And in terms of the stack that I showed you a little bit earlier on, I think of it this way. So if you want to use Ignite just for caching, you can use it just for caching and nothing else. In fact, on Monday at the IoT meetup here in New York, there's a gentleman who came up to me after the presentation. He said, we love Ignite, we use it for caching, we don't use it for anything else, because we find that those capabilities and those abilities of the technology serve our purposes 100%, and we don't really need to use any of the extra features. That's fine. What I think Ignite brings to the party is that it gives you the ability to take these components and apply them where it makes sense. So to give you an example, suppose I've got some kind of streaming that I want. Let's say it's through Flink or Spark or something like that. Data is being streamed in. I can use the streaming components, the adapters, to be able to stream that data in. Ignite acts as a sink. I can define kind of windows, event-based, time-based, or user-defined. I can do something with that data within that period of time, maybe run some machine learning algorithms on it, run some SQL on it, and then do some processing. So it really is up to you how much or how little of it that you want to use. In terms of development effort, because these components are very well integrated together, it makes your life as a developer a lot easier, because you don't have to go to some third party to get the functionality that you need to be able to do some type of processing. So Ignite supports that quite well already. Obviously, some of these components are far more mature than others. So for example, key value and the caching is originally where the technology and the ideas behind it came from. It was an in-memory data grid. It's moved on from then. So the SQL, the machine learning, all of these capabilities are being brought now. And again, because it's an integrated product, you can choose how much or how little of this you want to use. You may be a little bit nervous, for example, to commit yourself entirely to Ignite and use all of the components. I mean, that ties you into the technology. That's understandable. I mean, these are things that you have to weigh up in terms of risks and benefits that you get. But I will say that there are customers out there, and that's GridGain in addition to Ignite. The GridGain, obviously, it's a standard open source model. Give the software away for free, and then you charge for the other things, some of the advanced security and other features. But in both cases, you will find examples of companies that are using a range of these capabilities together. So one classic example, one great sort of used case, if you like, is Sberbank. They are based in the Russian Federation. And this bank, they span all 11 time zones of the Russian Federation. 70% of the Russian population have a bank account with this. And they are using Ignite, not just the caching capabilities, the persistence capabilities, some of the other capabilities as well. They're re-architecting their system from the ground up to use this. And they're using, each node has terabytes of memory. And they've got replication, multiple data centers to mitigate against potential loss. So I think in terms of the development process as a Java developer or as a .NET developer, as a C++ developer, or even other languages such as Python and so on, there's not a lot that you would see. Certainly the architecture you have to think about, and there are considerations in terms of building distributed systems. One thing, for example, that comes to mind immediately is, what about things like distributed joins? That will bring the cluster to its knees. You need to think carefully about what you're querying. So another useful feature that you get with Ignite, for example, is this co-location. Think of that hurricane that hit New York some years ago. Suppose I was a telco company and I wanted to send an SMS message to say, weather warning. If I use this idea of co-location, I can have a node that stores all the population of New York City on one node, and I can send that notification out immediately rather than having to query across my entire cluster. Okay, so these kind of advantages, I think, can be really, really useful. But again, it depends how much or how little you want to use. As far as the development process is concerned, I don't think there's a lot different. Yes, you're working in a kind of a distributed environment, and yes, you need to think about things carefully to ensure that cluster resources are used to the best effect. But Ignite can actually do a lot for you. And it's self-healing as well. I mean, it's the standard things that if a node goes down, it will figure out what to do. You define some rules and how it should behave, and it will follow those rules for you.
Buy your distributed object database book to figure out how to do things.
Oh, don't buy that book. It's terrible, terrible, out of date.
What's the licensing model?
Sorry?
What's the licensing model that you're using for this?
Licensing model, Ignite is free.
I mean, for GridGain support.
GridGain depends what you want to do. Okay, so they have various licensing. So this is the commercial. So the GridGain, the enterprise version, is built on Ignite. Okay, so it uses all of the Ignite features, but they add a few other things on top of it. And it really depends what you want. So for example, things like Snapshots or security and auditing, there's a range of things that training, support, bug fixes, these kind of things. I think Tom, can we may be able to help this gentleman. So just drop me an email or contact Tom. He's got business cards, and we'll be happy to follow up with that with you. All I would say is that, as I said right at the beginning, I'm here to tell you about open source. I don't care about GridGain, the enterprise version. Okay, nothing to do with me. So
yeah, quick question.
Yes.
So I evaluated Ignite some time ago,
yes.
And so this is more of a roadmap question. I realized you guys didn't have multi-tenancy, like you didn't have.
Okay. So that's a good question. So,
yeah, so
multi-tenancy.
Do you have any,
offhand, I can't answer your question, but I can find out.
Okay.
Okay, it's not something I've come across, but yes, excellent question. And I guess, just to, in terms of how to reach me, so keep in mind, all right, so it's first name dot last name at gridgain.com, and if you can spell my surname and you get it right, the email will reach me. There's about 8 or 9 different ways that surname is spelled, okay? It comes from South Asia. So you can see it with a Y and W and all sorts of other things. So you're very welcome to drop me an email. And if there's anything I can help you with, remember, my focus is the open source. If you're interested in the commercial stuff, drop me a message. I'll be happy to forward that on to the relevant people. But in the first instance, if you can't find any assistance, feel free always to drop me a message, and I'll be happy to assist you as best as I can.
Cool. Thank you very much.
Okay, great. Thank you.
Thank you all for attending.